So like this one is odorless. What is the alcohol?
No.
Oh, they're both.
Sharp.
Wait a minute. Shh. Hand? Yes.
The sharp odor.
Sharp, okay. Okay. If the water is consumable, what is the alcohol?
Non-consumable.
Okay. Not consumable. Consume, oh shoot.
Yeah, you
Comes
kind of
out.
totally did it.
Any other differences?
Volatile,
Volatile, what does that mean?
means it can catch fire.
Okay. Did you observe that difference with water? Or did you just
No,
know
no.
that?
Hey, water puts out
Need to
fire.
observe it.
Okay, not volatile.
I think everything
Okay,
would
so I'm
be
gonna draw
something
a
and
line
not.
here, okay. What else?
I saw the 50%, so I'm like, it has to be composed of something, two different things, or
Okay, so the alcohol maybe is a mixture?
a mixture of something.
Okay. Is the water a mixture?
No, not technically.
Whole, not a mixture, not a
Is it
mixture.
well water?
Not a mixture.
Well, we're going to say it's
Not a
not,
mixture.
in quotation marks,
That's not a
maybe.
mixture.
Good question.
It's actually a.
Would the water and alcohol comparison be like two human body things? Because when you're saying consumable and not consumable, because if you drink too much water and you drink too much alcohol, you still die.
This is.
That's why I don't drink water.
But if you drink your beaker full of water here, you will not die. If you drink your beaker full of alcohol, you still will not die, but you will not be joining us for the rest of the day. Okay, I mean, it will make you sick.
You will have
I
gastric
thought I was going
disturbance.
somewhere.
Yes, gastric disturbances,
Different
Tim.
places.
With the alcohol, don't you have to have an SDS? In the water you don't?
I don't know. I
Yes.
think,
Yes.
do you?
Alcohol is
You have to
considered.
have considered chemical. So you would have to have an SDS. And
Okay,
with alcohol, you wouldn't.
Percentage.
okay. Okay, guys, listen, please, listen. Elizabeth?
Can you mention that it evaporates faster? The alcohol evaporates
Oh,
faster?
that's good. The alcohol quickly evaporates? Okay.
Does that mean it has a lower boiling point?
Did we observe that?
But we
I didn't observe it evaporating either, though.
Did you not?
Well, we dropped a couple of drops and I sprayed it
You saw
out.
it diffusing.
Did that with water.
If you put it on your finger, you could have compared the evaporation rates.
Yeah, you could.
Okay, let's go ahead and stop there. And with our comparisons, Timothy,
The alcohol felt oily in the water, didn't
okay?
I disagree with that.
it? You didn't feel it, I did.
I don't know what oily feels like. I think of oily like lotion, it sticks on your hands. Alcohol.
Okay, now, how can we use this chart?
How?
So we have our data here, we have our comparisons, we have our similarities and our differences. So when you're writing, this is everything you need to write when you're writing up your comparisons here. There's just some filler words you need to add. Everything is right here. It's done. You just have to write it out in sentence form. Water and alcohol are both liquid, clear, and have high viscosities. The water is odorless, whereas the alcohol has a sharp odor. The water was consumable, whereas the alcohol was not consumable. So you see where I'm going? You can use those comparative words like whereas, but, things like that compare. So you go through each point to compare them. Or you could do them together. The water was odorless, consumable, not volatile, It's not a mixture and it evaporates slowly. Whereas the alcohol, and then you can have your list there. So it really simplifies the writing process so that it's not as big as we think it is, or sometimes think it is. Did you have a question, Alyssa?
No, that's what I was asking about the writing portion of it, that you can turn into a writing piece, compare and contrast.
Okay. So we put our alcohol into we put our ice cube into the alcohol, ice cube into the water, and we saw what happened. Some of us got some mixed results, right? I mean, we didn't see the same results everywhere, and I don't know why. We'll see. So what happened to the ice and the water? If your ice went to the top of the water, give me a thumbs up. If your ice went to the bottom of the water, give me a thumbs down. Did the ice float in the water?
Yes.
Okay, so that was pretty consistent, right? So what does that tell us about the ice compared to the water?
But the ice is less dense than the water,
Because
because it floated above the water.
the ice floated in the water.
Yes.
Okay, all right, good, thank you. Now what about the ice when we put it in the alcohol? Did the ice float in the alcohol? Yes. Thumbs up. If the ice sank in the alcohol, down. Okay, so y'all's floated in the alcohol and y'all's floated in the alcohol. But everybody else got sinking ice in the alcohol. Is that what I'm seeing? So I wonder what the difference was between these two groups and the other four.
Somebody pour water.
Did y'all have 50%?
What was your percent alcohol?
Because I saw a bottle. I saw a bottle of 50
What
and
was
we had
y'all's?
70.
Okay, maybe that was it.
Because I saw 50 over there.
Okay, that's a great thing, is that we need to use consistent amounts of pure alcohol. That's good, thank you. Okay, so why, we had the behavior, Melissa explained that the ice was less dense than the water, so the ice floated. What about the alcohol, except for you guys, front and back? What about your group right here? Why did your ice sink in the alcohol?
Oh, ours didn't sink, ours floated, but we had the
Theirs was
50%.
Oh, I'm sorry, I thought y'all had your thumbs up, but
It floated.
It
Okay.
flows up.
yours,
Float.
okay, so this side had 50% and your ice floated in the alcohol. Okay, let's move over to this
I think you
side
did
of
this
the
on
room with the
purpose.
70% alcohol. Your ice sank in the 70% alcohol. Why?
Because it was, because the ice was more dense than the 70% alcohol, which is why it sank to the bottom.
Beautiful. Okay, does anybody have anything to add to that? Okay, now, we compared the ice to the alcohol, we compared the ice to the water. But what about the three of them? Can we rank those three substances in density order from least dense to most dense? How can we do that? Somebody want to share what you got, what you came up with for that? When I say somebody, I mean Candace.
We said, so you're asking for explanation?
Well, how did you rank the
Oh,
densities?
we said water, alcohol, ice,
Water,
from
alcohol,
most
ice.
to least dense.
And now her findings, these guys' findings are gonna be different than everybody else, because your ice was less dense than even the alcohol, right? Because your ice floated in the alcohol. So yours was water, alcohol, ice. Okay, good. What about you guys? What was the order of densities in 70% alcohol? Quentin? What was the least dense?
The least dense would have been the alcohol,
Then,
then you would have the ice,
then,
the water.
okay.
Now, I have a question though. I don't see how they can rank theirs, because if the ice took the same action at a time without mixing all three substances, you're using the ice to do the relative density across both liquids.
Okay.
The ice performed the same action in theirs, so they can't, without mixing the water and alcohol, they can't
since we didn't.
Yesterday we did.
Well, I'm saying based off of what we did
Just today.
today,
Okay.
you wouldn't be able to.
So how could they then
If they
do
mix
that?
the water and alcohol, they would be able to.
Okay, so you're saying that they need to do a comparison of the water and the alcohol to be able to properly rank that?
Yes.
Okay, good point. How did y'all decide about the water and alcohol, which one was more dense?
Oh, because when we dropped the ice cube in and the ice was starting to melt, and it was.
Okay.
We
So
can't
they-
hear back here.
Oh,
You can see it with the
Can
color.
you turn around and tell them that?
So
You want
what
to
we
see?
observed was when we dropped the ice cube in the alcohol, the ice cube started to melt, and the melted ice is water, and we observed that that it was sinking to the bottom. That coloration was sinking to the bottom.
Okay, Toby?
We also noted as a group that when we put
As what group?
as our group,
Oh, as a group.
we noted that after the ice melted, that most of the coloration was near the bottom, but the volume of the ice and the alcohol as compared to the ice and the water was less, which meant that evidently there's something occurring at a molecular level where water and or alcohol is fitting in between the other molecules.
Okay, that's interesting. That would be an interesting further investigation
Sure.
to see how that works. Yeah, that's cool, thank you. So we ranked the order, we gave evidence, and I think that you guys have emptied your beakers and dried your beakers and placed them on the table. I see some more alcohol. If we could get the alcohol over there back to the table, that would be great. And then we reflected back on the column, the cylinder where you put all of the liquids in there, and the objects, the solid objects yesterday. And you explained now, you came up with an explanation why you thought those liquids went in the proper orders that you placed them in. Would somebody like to share that? And I'm sorry, I mean somebody like Toby.
Could you repeat the statement?
Number one in your student guide, why did you, yeah, there you go. Why did those layers occur like they did in the column yesterday?
Each liquid has a different density in comparison to the other liquid. So each liquid will find its place or density level as compared to the other liquid.
Okay, and how do you know where they're gonna go?
Oh, each will go to its proper location. Each liquid will go to its proper location since they have the same volume but different masses. Those with the largest mass will be lower than the respective liquids with a less mass.
Okay, if they all have exactly the same volume.
Right, that's what I said with
Okay.
the same volume.
Okay, what if they didn't have the same volume? What if in your column you had, I don't know, a fist-sized volume of the syrup, but you only had a teeny tiny little pinky-sized volume of
It
the
would be the
Blue Dawn
ratio
soap?
of the mass as compared to the volume.
It's the ratio of the mass to the volume, okay? And what do we call that?
Density.
Density. Okay, good, thank you very much. Here's our Steve Spangler density column. Yeah, Brandon?
Yeah, could we have just put them in any kind of order that we're still doing? That's what I thought yesterday, but I didn't want to be wrong.
No, yes, I think you're right. It will,
They were
it might
naturally-
take more time than we had to
They
show
were
yesterday.
naturally-
And you have to be careful too, because some of those substances will diffuse into each other eventually. So,
And the
you know,
food
like,
color.
if you did oil and water though, for example, those are not going to mix. So you could, you know, do it with substances that will not mix. All right, so now, in your student guide, you have rewritten what is your density definition. You're writing it in words, not with the formulas or numbers or anything. And we're explaining what that means. Elizabeth, would you share what you wrote?
Which number? We're on,
The second page where it says density defined. What is density?
oh, okay. I didn't write anything, but I wrote it on here. Oh, the beginning. My new definition of density, that the object or substance measure of how closely or spread out the particles are that make up that substance or object.
Okay, do the particles matter? What the particles are?
It doesn't matter what it is, but it's just a matter of how closely compacted they are.
Okay. What if I had atoms of lead that were as equally packed as atoms of hydrogen?
Well, then it's determined by the mass and volume, the relationship of the mass and volume.
Exactly, yes, it's the mass of an object in comparison to its volume. Yeah.
You're not gonna use atoms with the
Okay,
Do you have to use mass? Could you just say matter? It's defined as the amount of matter.
what is the amount of matter?
The amount of matter per volume of that matter is density.
But what is the amount of matter equivalent to the mass?
No, I said per volume of that matter.
That's what I'm saying. If density is the amount of mass in a volume, in a certain volume, is the amount of matter equivalent to the mass? If
Per-
it is,
per
then you
volume
can
of that matter.
substitute.
Yeah. Oh, that's density.
It's just a
You see what I'm saying?
Yeah.
Okay. Okay, so, your face partner. Look at your face partner. Does everybody have a face partner? Brianna, I will be your face partner. I want you to explain to your face partner in 10 seconds, and the person with the shortest hair is gonna go first. And Brandon, you win. And then you're going to swap roles and share, the other person will share your definition of density.
I'll put this something is oh, I said
Okay, time's up. Now, look at your handout, revise your definition if you need to. I'm gonna give you 5 seconds to revise your definition. Now, turn to your shoulder partner. This is gonna take a little thinking because some of y'all have more than one shoulder partners. And I want you to share your revised definition with your shoulder partner. Okay, thank you.
I think he's still listening.
All right. Now, all day today, think back to the ball in the cold water, the ball in the hot water, our watermelon, our grape, our water, our Coke, our Diet Coke, the alcohol, the ice, the water in your beaker. Did we measure anything? Did you take any mass measurements?
No.
Did you take any volume measurements? Okay. So did you calculate anything?
No.
There was no math, no numbers in any of this, right? We just observed behaviors of these different substances, right? So even though we still don't know the exact densities of anything that we touched today, can we compare the densities of these objects to each other? Okay. So we know the density of an object relative to the density of another object. These are called relative densities. The relative density of two objects is how you can predict the behavior of these objects, right? So when you hear somebody say that heat rises and cold sinks, does heat rise? Does the heat rise?
Heat's not a thing.
No. But why do we say that? I mean, that is wrong,
Easier.
right?
Because cold.
Why do people say that? Now think about this, wait a minute. What is a better explanation that we can use rather than heat rises and cold sinks? What is the truth? Rochelle,
You actually called pull that stick.
I did.
Oh, yeah?
Yes, I did.
Heated air molecules are more spread apart, so they rise, travel.
Travel up.
So, the heat,
Oh, wait, got it. Got it.
just a minute, listen.
Heated air molecules become less dense than room temperature molecules, which makes them float.
Float,
Rise.
wait,
Who's
Above.
Who's that?
Next to heated air molecules rise
okay, so you're
above
saying that
the,
when air, if you take a certain volume of air and you add heat to this volume of air, what is going to happen to the volume of air?
what is going to happen to it? It's
What will
going
happen to the volume of air? You said that the particles will what?
become less dense
The particles become less dense? Or,
molecules.
okay, the molecules of air, let's say I have a area of air right here, okay? Now, this air got hotter, what's gonna happen to the air?
Her hand is a balloon.
Yeah, my hand is a balloon.
Oh, okay, that makes sense.
Okay,
It's going to expand.
okay, so what is expanding?
The molecules.
The molecules, so what is
So
the
the
measurement I can
volume is
take? The
increasing.
volume is increasing. Now, if you think about density as a ratio of mass to volume, okay? You just increased the volume. So if you increase volume, what is that going to do to density? So
Inverse.
So if the volume increases of that air, now don't think about that.
Okay.
If the volume increases in the air, what's going to happen to the density of that air? You said that it
The increases, it's going to
you said it's gonna rise up because it is,
less dense.
it's less dense. So, now think about what you just talked about with that behavior. The volume increased because it was getting less dense, so it rose up. It's still the same amount of air,
Right.
right? The mass is still the same, but it's taking up more space, so it's rising above the more dense air because the density was lower. So you increase the volume,
The density went down.
so the density decreased, and the mass was kept the same, okay?
That was the concept.
So you would have to specify the mass, Steve,
Right, we were just talking about a fixed amount, fixed,
of air.
yeah, got it? Okay, so, Toby,
Okay, now, I wanna tie this into a lesson.
we're gonna do teacher talk later.
Okay,
Okay,
you write
write
that
that down, yeah, good job. Okay, now what about if that air were colder? What if it got colder? So think about that. That same amount of air, rather than getting warmer and expanding, it got colder. And what's gonna happen to the air when it gets colder? Melissa?
It's gonna become more dense and the
Why
volume
is it
is going to
become-
decrease.
Okay, so when it gets colder, the volume of air in my hand balloon will? What's gonna happen to it?
It's going, the volume
The volume is going
is going to
to
decrease.
decrease, therefore,
It is going to become more dense,
uh-huh,
and it's going to sink.
okay. So, you're saying that in our ratio here, the volume, what did it do when it got colder?
It's going to decrease,
Okay, the volume decreased,
which causes the density to then increase.
right, like that? Okay. All right, cool. Now, let's see.
Let's see.
I think I can get in here. All right, we're gonna take a break now.
16 minutes.
Not 60 minutes, 60 seconds. Go fast.
We have some snacks back here for you. We have some healthy snacks of juice and fruit, and they may be unhealthy, but I can't see what it is. Let's go get them.